So for this example, let's study the classic and familiar function f of z equals 1 over 1 minus z. Feels like an old friend. You've been seeing this guy since you were in Calc 2 or maybe even sooner in your career. Who knows? Well, let's remember that this is equal to 1 plus z squared plus so on and so forth. You can write this as the sum n equals 0 to infinity, z to the n, and it's valid for the disk modulus of z less than 1, which I've drawn right here. And by the way, that's a Taylor series, but a Taylor series is a Laurent series. So if you want to look on this annulus, this disk, then the Laurent series for f looks like that. But what if now I want to look out here? What if I want to find a Laurent series expansion for this annulus? And I'm just going to think about this as the green annulus here. Whoops, I'll write it in green. The green annulus was going to be modulus of z bigger than 1. And so if you think about it, it seems like this function, and in fact it doesn't seem like it is analytic everywhere except at 1. So if we delete the unit circle, we're deleting that problem point here where the z equals 1. And so we're analytic on this region, and so you know that you actually have a Laurent series expansion on that region, and now it's a question of finding it. How does one find it? And so let's see if we can do it. Well, first off, let's realize that if the modulus of z is bigger than 1, then 1 over the modulus of z is less than 1. And that kind of gives me the key here, is that I'm going to think about it looking to end up with a 1 over z in my original formula. So I'm going to start with 1 over 1 minus z. And I'd like right here to get a 1 over z, because then I can use the classic geometric series expansion. So I'm just going to do some algebra. I can write this as minus 1 over z, 1 over 1 minus 1 over z. There's really nothing too tricky about that. You just do the algebra to get what you want. When you multiply that negative z back through, I haven't changed anything. And now I'm super excited because this I can write its geometric series expansion for, and it's actually valid as long as the modulus of 1 over z, this guy, is less than 1, which we're assuming it is. So this is equal to, this is equal to negative 1 over z times the series n equals 0 to infinity of 1 over z to the n, right? I'm just using the classic geometric series. And now I can pop this z inside and write this as sum n equals 0 to infinity minus 1 over z to the n plus 1. And depending on what you're up to, I'll just show you. If you wanted, you could start this series at 1. It doesn't matter. You just want to make sure we're all comfortable switching our starting indice. We can write out some of the terms if we want to. Negative 1 over z minus 1 over z squared minus 1 over z cubed minus so on and so forth. So now let's realize that when I have this series, f of z equals 1 over 1 minus z, if you're inside the disk, the unit disk, open unit disk, then your Laurent series is just your Taylor series. It's just n equals 0 to infinity z to the n. If you're in this annulus modulus of z bigger than 1, then that's what your Laurent series looks like. So I think we'll stop this video here. This one might be a little short. That's okay. I'm going to have several parts, and let's do another example. We're going to use this representation actually in the next example.